I just started with opening Pycharm. Pycharm is this app right here. I opened it, I get this page. And then in Pycharm, everything is organized into projects. Because as per Pycharm, their intended use case is not people who will randomly open the thing and start coding. It's for people who are coding seriously. When the issue is serious, they want us to use Pycharm. Otherwise, we could use IDLE or anything. So they mandate us to use projects organization for everything. When you use projects, uh, it's similar to a digital systems projects in that software. You put a bunch of files together, they identify as a project, and the thing about projects is that they can have more common features. For example, they could act as a single Git repository, or they could be assigned a virtual interpreter. Wait, it's called an interpreter in a virtual environment. Yeah. So here our intention is to use Git for this. So first of all, the difference between Git and GitHub. Git is a system sort of thing. It's the framework on which things run. GitHub is one company that uses Git and provides services to its users. Like in the name Git and Hub, Hub is a place where people come together for something. So people come together at GitHub for using Git. So that's the thing. So in Pycharm, when you get this option on top right, get from VCS. VCS stands for version control software. Git comes under the category version control software. Again, version control software is a general English term for this. And Git is one particular framework which you're using. There are other frameworks like that. I think Pycharm only supports Git. Yeah, it supports Git, Mercurial, and Subversion. We are going to use Git. And the reason why it's called version control. So let's say this is my project. This dot is my project. I then make an edit to it and it becomes this. So this is my version 1 and this is my version 2 or 1.1 or 1.01 or whatever naming scheme I use. So your project exists as different versions. And what Git does is that it creates a history of these versions and also creates a framework for people being able to collaborate with each other. Bhuvana, have you learned SQL or any
No,
database management?
no, I haven't.
Fine, all right. Okay. So what these versions essentially are, we can say they are instances. Instances basically mean that at a particular instant of time, what is the way the thing is. That is the instance of that at that instant. So let's say a car is moving and is going this way. So at time t is equal to 0, it's present here. And then at time t is equal to 1, it might be present here. So this is one instance of the car. Actually, not this. The whole road with the car present at this location is the instance at time t is equal to 1. If you take the road as a whole and at time t is equal to 1, if you're able to check it, then nothing would be present at this 0 position. If you're checking at t is equal to 1, it will only be present at 1 position. If you're checking at t is equal to 0, it will only be present at 0 position. But the road is common for both the cases. So the difference at different time instance is the different instances of the car. Similarly, we apply the logic for software versions. So we have two versions right here. And the version which I'm talking right here, it is not the release version. So like if I'm saying Instagram app, Instagram might have version 26, and then tomorrow it might give a release and say this is version 27, just update your app. So in between these two versions, it's not like a coder just sits for 1 hour and does the whole thing in one go and then releases the next version. Each version will take weeks or months to develop. And between these weeks or months, there are many sub, uh, I should say, like checkpoints where the coder would stop. So in the release versions itself, they give like 26, 26.1 with bug fixes and all that. But then even between these two release versions, there are many internal versions which the company will use. So the company will have checkpoints for themselves internally, even if they're not intending for anyone else to see it. So when they're doing that, we use this version control software. Actually, I'll show you an example. Understood up to here? I'm going to take that as a yes. Okay. So this is one project that I have. And then it started here with the initial commit. And then after a few hours or so, I made this version. And then this. And then this. And so on. And then in each version, I would have made some particular changes. Like if I open this, no, this is not what I expected. Yeah. So here, if I check this particular commit, a commit is to basically save updates. It's to say, like basically in my diagram, each version is a commit. I'll come back to the details later. So here, I can see the differences between the consecutive two versions. These lines of codes were added, and these red lines of codes were deleted. So like between each version, there are like small changes like these and all. But then this was just a small checkpoint that I saved. I do not intend to release it to my users and ask them to like update their app just because I did this small changes. The point where it would have told them to update is this, when I made some big changes. So like this whole thing, it wasn't in one go. It's a collection of all the changes starting here, the second commit, all the way up to the second last commit. So that would be my release version. And I named it like that, first version, because that's my first release version. But everything inside is also a version within my version control software. So in Git, each version that you're saving is called a commit. Or rather, commit is the action of saving your particular instance. Like right now, if I'm coding something, this might be my code right now, and then I add a few words. I might be able to continue adding so and so and so and so. But then I will stop here and I'll decide. At this point, there are enough changes that I can save it at this point, and that saved point will be shown to all future users like this in the history. So to at that point, I'm saying my code is good enough to be shown to others. I'm going to commit to this. And the reason it's named like that, commit, it's like basically once you commit it, you don't come back and change the stuff in the history. If you want to make a change, you will have to make another commit that makes the change back to the original version. So like even for undo, once you have committed the previous version, if you want to undo it, you have to undo it and then commit it again. So once you just send it, there's no going back. That's why it's called a commit or commitment or whatever. Commit action. Okay, let's go to starting it up. As I said, version control software is Git. Framework is Git. In that, you can click here to link your GitHub account. And these are all your GitHub projects. There, I'm going to choose rough sheet, which is my rough sheet for practicing GitHub or Git. And then when you click clone, what happens is that there is a copy of rough sheet, the project, inside GitHub servers. So that is called my remote repository. Basically, repository is the Git's term for projects. Repository is basically a collection of codes, and Git calls a collection of codes as a repository. And there's a difference between a project and a repository because a single project can have multiple repositories. Like my project might be like a government scheme or something. And within a government scheme, there might be multiple apps that users can use. And each app might be given its own repository and own team to code it. But as of right now, projects and repositories are almost the same thing. So I'm going to use the word repository from now. So this Git repository is present in GitHub server. And a server, it's like I don't have it with me, but I can access it anytime. So that's why it's called the remote repository. I can access it from anywhere, anytime, but it's not with me. But to make changes to a code, I need to have a local copy of it. So that will be my local repository. And to get it locally, I need to clone it from the remote to my local system, which is what we're doing. We are basically opening the project. It will take a while to clone. This is a warning because any code you write is dangerous because code is literally giving you access to the system and all that. So you need to trust what you're opening. Or you could preview it in safe mode, which will not let you make your edits, but you can just preview what it does and all that. So let's say I was assuming you know how to use Pycharm properly. I'm just going to create a new file, Python file. Name it .py. Put Python file. Enter. And then any file I have. Oh wait. Okay. Go ahead. Any file I have, I can choose to keep it locally on my device alone in my Pycharm project. Or I could choose to add it to my Git and share it with everyone else, upload it to the remote repository and all that. So here I'm going to choose to add it. So it's showing this in green, which says that it's a new change I have made. It's a new file I've added, and it's not yet stored in the Git. I am still editing it. There has been no checkpoint. There is no commit for it. It's going to be a future version. But since it's a new file, I'm adding something. So it's in green. I'm not removing something. And then I type something. And the reason why version control software is so important is that, let's say I make a third version of something. I come here. But my friend might not be in the third version by then. He might be working on the second version. He might have cloned it to his local repository. And in his local repository, he made a change and he made a commit. So now I have two alternate paths. And then basically, let's say this line is this local repository. And this is my either remote or my repository. Let's say this is the main remote repository. Once I bring it to local, it would, and then I make a commit. So this is a new commit. I brought it to local, I made a new commit. Now I want to send it back to my remote repository so that others can use it. So bringing it to the local is called fetch. And then sending it back is called push. So we have fetch, commit, and push. These are the only three things I have told you to learn. When pushing, this process of bringing it here is called merging. In case your code has no conflicts, like I'm working on a different file, you're working on a different file, even though they're the same Git repository, the Git or GitHub will be able to notice that and it'll be like, there are no conflicts between your files. You can automatically merge the things. It will take care. Otherwise, if there is a conflict, it will be like, you both are working on the same code and you both have not written the same thing. You can you can resolve the conflict by choosing which person's code to go for which particular part. But for now, you can just focus on merge automatically because I don't think I'll give you any course which will have this thingy conflicts. If any conflicts, I will take care of it myself and resolve it. Yeah. So coming back to Pycharm, in the bottom right, you see the symbol. This symbol is standing for version control software. You can see it like there's a main branch in the bottom, and I draw it downwards, but I drew it downwards, but Git is drawing it upwards. Wait, you can see the bottom left. There is a section called Git. This shows my Git related stuff. And here I can go to the log. I can see the commit history. So Git is going from bottom to top. I mean, Pycharm is going from bottom to top. I created a new branch, merged with the main branch, created a new branch, merged with the main branch, and now I'm here. Okay, a branch. What is a branch now? It's like within my remote repository, I can have multiple branches. And in each branch, I can assign a different team to work on it. And once the team is done as a whole with the purpose of that branch and everything, at that point, we can merge it with the main branch and be like, we can resolve all the conflicts at once instead of having to resolve conflicts every time you have to push it to the remote. So by having branches, you can parallelly complete your work. And once everything is done, you can merge it together. So this, the top bottom right, it shows what you have. So it shows the remote branches is origin main. Origin is my GitHub in this case. And main is the branch name. So that is the remote branch from which I fetched this project. And that created a local copy called main. So you won't need to create any new branches or anything for my projects. So you just need to know. And this thingy is called fetch. It's a downward arrow. It says that you're bringing it from the cloud to your local device. So when I fetch stuff, it checks the remote for any new changes. And if there are any new changes done by someone else, it will fetch it to my device and it will show me a option to like merge conflicts and all that. And okay, I've written this code now. Now I'm sure I'm done with this code. I wanna, any doubts till now? Yeah, pass.
Your main was already a local branch, then why would you fetch it again?
Main is not a local branch. Main is given now origin main. Origin is my GitHub. And there, the main branch is there. And when I cloned it while opening the project, it created a local copy of that main. So this is my local main. What was the doubt again? Why would we?
No, the thing is, there was above the main, there was something called as local branch, right?
Yeah.
uh, in the rightmost down direction.
Yeah, got it. Yes,
Yeah.
understood.
So since it was already in your local repository, why would you fetch it again? Was my question.
Okay. While you're cloning it, it automatically gets it. And now you have it, and I am working on it alone. But then, as I said, parallelly, my friends could work on their Pycharm, and they all have their local clones. And when uh, pushing from a local clone, they won't push it to my device. They will push it to the cloud. They'll push it to the remote repository. And from the remote, I am supposed to fetch it whenever I am ready to fetch it. Like, for example, I'm writing a line right now. I'm in between writing a string. I won't want to fetch it right now. I'll finish it. And whenever my work is done, when I feel ready to fetch the stuff, I'll fetch it. So I fetch it. I got it. There were no conflicts or anything. Fetch successful, everything done. Any other doubts? Okay. Don't hesitate to stop if you have any doubts. Okay. Now let's say we are done with this code. This is what I want to do for now, and I want to commit it. I will use git commit, or I can do control K, which is what I prefer. And when I'm committing it, no, this is not the view it will show you. One sec. It changed my view for me, but I forgot how to change it back. Uh, Yeah, got it. Okay, so this is what it shows you normally while committing in Pycharm. So this is the list of files that I have in the project, and I can choose which files to commit or not. Here only one file had changes, so only one is available to check or uncheck. But if you have multiple, you can decide which files to commit at what time. And actually, if you learn advanced Git, you can even decide which parts of a file to like commit at a time. But for now, let's just leave it with this. And here you have to add the commit message. So a commit is something we do when we are sure that, okay, that part I told you already, when we are sure that the code is good enough to be shown to others, the code has to be executable whenever you're committing. You shouldn't write a code with, commit a code with bugs and everything. You have to run it in your local system first, fix the bugs, and then commit it. Or actually, fine, yeah. And
Balu,
then, yeah,
can I just commit with, like in my own private branch? It's not like I have to commit only when I mean, I get it that you have to commit when your code's ready, but to the main branch, right? I can do whatever I want with my private branch.
yeah, that was the part I was about to say. Yeah, you
Oh,
can
okay,
commit
okay.
it, but it's a good habit to commit it when your code is working. It makes it easy for debugging.
Cool.
Like
Okay.
you'll have a history of changes to make, and then if you have a logical error at a later point, you'll want to come and run each version to see where the logical error originated from. If you have commits with syntax errors, you won't be able to run it. So it'll be a hard job. And then a commit should be like a complete change. Like if you see here, for each commit, I was able to give a proper description and everything, passing text input, slot times down, etc., etc. So I can't just be like I wrote one line and commit it. Or like for example, I wrote two functions. So I'm writing two functions, and let's say each function has like 20 lines of code or something. So commit is not something you do at the end, like when your code is completely ready or anything. I can commit it even when this one function is done, and this other function I can write it later. So as and when this function is done, if I commit it, then your commit size will be small enough for it to have value. Otherwise, if it's too big, it'll be like reading through your whole code at once again. There's no point of having a commit and giving a commit name, description, and all that. So this thing which is given here, the heading, is the commit message, which you will type here. And then I just click commit. That's all. No changes to commit now. One file already got committed. And now, once I've done like 4 or 5 commits or so, I want to send it to my main remote repository. When I'm like, all my functions are done. The feature I'm working on is complete. So I can show it to my friends and be like, it's not just executable, my task itself is done. At that time, I want to push it. Push option is here. Okay, fetch is here, commit is here, and push is here. Control Shift K. I just put it. It'll show a history of my commits. I can choose up to which commit I want to see. And then I can choose which branch I want to commit it to. Here we only have one branch, which is the main branch. But then if you're working on a project with me, I'll probably create a branch on your name. So you will have to commit to your own branch alone. You shouldn't commit to the main branch. And once all your pushes, push to your own branch. And once you push to your old branch and everything, from your branch, I'll be able to pull it to the main branch and then merge all the conflicts and all that. If you directly put it to the main branch, it might show you conflicts and you'll have to fix all that. And no one will be there to review your code before you commit it. Before you, commit it, works. So here I will just push it. And done. It's gone to the remote repository. So that is git fetch, commit, and push. So push is something we'll do, like, for example, I'm working today, and I told your thing has to be complete, but it's not always that way. So like, you have your own branch anyway. And let's say I'm working right now, I made this commit. I continue working for the next half an hour, I make another commit, and so on. And let's say after 4 hours or so, I'm done for the day, I want to go sleep. At that time, it's a good idea to push it so that in between the 12 hours or so, if your boss or someone wants to come and check your progress, they can go see it in the remote repository. Or if it's like, or sometimes what happens is, I was using GitHub for my old project, which was before I joined VIT, basically. And that JE type. No, after JE, that holidays, 4 weeks only I got summer holidays hospital time. At that time, I was working on a project and I worked on it for like 2 weeks. I had all the changes committed in my local repository and all that. And then I did push it and my laptop stopped working. And the 2 weeks of work is no longer accessible. It was stuck in my local repository, never committed, never pushed it to my remote repository, so I can't take it back in my new laptop. So it's better to like push it when you're done with your work session. So like 4 hours if you work, you push it, you can come back later, you can continue with new commits and everything. But as I said, don't push incomplete things. If I wrote this half string, don't push it, don't commit it itself. Pycharm has a built-in save feature. So like, for example, I left it here and I'm going for 4 hours or so, I'm going offline, I'm going to sleep and come back. I might have written only these 3 lines right now. If I come back tomorrow morning and these 3 lines disappeared, it's not a big deal. I can just write them again. But then the value of not committing it was that all your commits were executable. That's all. We talked about what is it, how to do it, and what are the good practices to do it. Any doubts? Okay, I'll assume not.